Hello everyone, I'm Siddhant Rai and I'm here to present a mobile app on stock prices and performance called Stockly. I'm here with my colleague Tarunkumar Reddy. I will see the introduction. So Stockly is a mobile app which we use for individuals to organize, track and monitor their favorite stocks efficiently. The app provides an easy to use interface, real-time updates and a personalized My Stocks list. So now basically we aim at simplifying the stock tracking experience for new and experienced users alike.
So the target audience who will be involving in these are the retail investors and those they're the young investors and the experienced ones. The young investors can be interested in the user-friendly platforms and then they can learn from the news feeds like that. And the traders and the financial professionals will be who are experienced in traders, analysts, and advisors. They can help. They can seek the advanced analytics and they can use it for their daily life. And the retail investors, they begin and self-manage. The beginners and the self-managing investors look for the ready-to-use tools and the educational resources. Students and global investors also can be included in this because we have the stocks from overall international.
So our problem statement here is to manage and track personal stock investments, which can be complex for users who lack access to intuitive tools. Managing multiple stocks investments can be overwhelming without an easy to use platform. So we need a platform where users can curate, analyze, and view stock trends seamlessly. Next is technical stack. So we see that for our front end, we have used Flutter, which is basically for UI design and navigation and also provides state management. For backend, we have Firebase Firestore, which is a real-time database for user data and stock management. Then for API, we have used Stock Market API from FinHub, and tools for testing and platforms for version control. It is a GitHub. Tools for testing is Android Studio and Xcode, and so for user login, we have used Firebase authentication.
So the app overview as such. So initially we have the login screen where we can, after we are logged in with our credentials, we can move on to the stock screen. And in the my stock screen, we can choose the stock screen where we can look at the price screen and then the settings screen. Then when you choose the stock screen, you can go to the my stock screen and you can add the stocks in that my stock screen. Later on from the my stocks, you can go to the stock price and then you can look into the news feed which is in that page, and also you can go to the settings screen to update. And the testing is like we have done the unit testing, the basic search and the stock edition. We are fetching data from the Firebase and we have integrated testing as well. We have tested the UI components with the Firebase integration where we have stored the data in the Firebase, and the manual testing is done with the real world iOS and Android devices simulators. And the detailed explanation, initially we have a user model which has ID, name, and stocks. So these are the initial model that we have been using. The purpose of this is to this class defines the structure, and then the constructor in our user is going, it constructs, ensures all required fields are initialized, and the key design features are the class enables structured data handling for the authentication and preferences, and the stock attribute is critical for managing user selected stocks.
All right, next we look into the authentication screen. So this is the authentication screen is responsible for toggling between the sign in and register screens. The key feature here is that it's a stateful widget. It tracks whether to show the sign in or the register screen using the show sign in boolean. And the main functionality includes toggle view and build. So as said earlier, toggle view switches between both screens, and the build displays the appropriate screen based on that value. One of the key design highlights here is the modularity. The sign in and register screens are encapsulated in separate widgets, which keeps the structure clean. Next, we see the register screen. So the register screen key components here are first the loading indicator, which displays a loading animation during the registration process. Then we have the email field to input the email, the password field, and error handling, which basically displays error messages if the registration attempt fails. And finally, we have the sign-in redirect, which is a button to navigate back to the sign-in screen. And we have the sign-in screen next. So the sign-in widget is a stateful widget. It manages user interactions and UI updates. Here, a loading state is used to display loading spinner. So if loading is true, the loading widget is shown. The next one is the auth service. So what happens in this is it connects to the custom authentication service class. This uses the sign in with email and password method to sign in the user using the entered email and password. Next is the validator. It checks basically whether the input is valid or not before submission. Then we have the form layout. It uses a form widget with a global key to manage validation and submission. There's also error handling to display an error if the error string is not empty. And finally, we have registration redirect. This redirects the user to the registration screen by calling toggle view, which is basically a callback function. Now the next one is main.dart. So the main file basically we start by initializing Firebase. This uses platform specific configuration from Firebase options.dart. We also ensure Firebase services like authentication and database are ready to use. Then we have widgets Flutter binding, which ensures Flutter engine services are initialized before setting up Firebase. After that, the main application extends a stateless widget, which serves as the root of the application. We also define the roots, especially for the news feeds and all these things. It's mapped under the news feed screen widget, and we pass an empty stock symbol list for initialization. So the key features here include Firebase powered user authentication and database handling, stream-based architecture for dynamic updates of the app, well-structured navigation using the wrapper class, and predefined routes. This provides a future-proof and scalable foundation for adding new screens and features.
So the home screen is used to display the user personalized screen based on the persons that they have. They will be displaying the stock. So it displays a personalized welcome message and using the user's stored name from the database. And there's an interactive navigation, top stocks, navigate to explore the top performing stocks, and my stocks to view and manage personal stock investments, and settings to update the preferences using a model button sheet. So this is how the structure looks like. And in the settings form, we just have a update button where the dependencies, which dependencies include the cloud file store using for accessing the file store database, and the provider to manage the user's authentication context. And in the state management, the settings form widget is using a stream builder to listen for the changes in the file store document, and this retrieves the current username from the file store and displays it in the form on the top. And the form functionality uses a text form field with the initial values set to the current name fetched from the file store. And when we update it and click on the update, then we can view the new updated name. And with the file store interaction, there's upon the submission, the updated name is written back to the file store.
Next, we see the choose stock screen. So this is a Flutter app screen that is designed to allow users to search for, select, and save stocks they are interested in. The key features here are a search bar where users can type in and search for stocks. Then we have dynamic stock list, where the list is filtered in real time based on the search query. Users can tap on a stock to either select or deselect it. And finally, the selected stocks are saved to Firestore under the current user's document, specifically in the My Stocks field. Next, we'll look into the My Stock screen. So in this screen, again, we have a search functionality allowing the users to filter the displayed stocks based on the company's name. Then we have an interactive list of stocks and also floating action buttons. One to add new stocks to the profile and another to view the latest news related to their chosen stocks. Talking about the code design, the app uses the provider package to access user details like the UID, which is used for database operations. For separation of concerns, all database queries are handled by a database service class, which helps keep the code clean and maintainable. And the build stock tile method encapsulates the logic for creating a consistent card design for each stock. The next screen is the news feed screen. You can also see a snippet of each of these screens showing on the right side. So what happens here is, first we have fetching news. The app uses an API key to fetch general news articles from the FinHub API. For state management, the app uses a loading state called loading, which is initially set to true. When the news article are fetched, the state updates and the UI reflects that change. There's also refresh functionality, so users can pull to refresh the news feed. For error handling, the app displays an error if the news fails to load or if there's no available news to show. And finally, opening new news links. If the user taps on a news article, it will launch the URL using launch URL and the URL from the URL launcher package.
So this is a stock price screen, so where we can go through the code which has the UI parse and init state. So this initializes the WebSocket connection and subscribes to the socket symbol, and later it sets delayed function to stop showing the loading spinner after 1 second. And the stream builder is another function that we have used. It listens to the WebSocket stream, and depending on the data received, if ping is received, it shows the loading spinner. If the stock data is received, it displays the stock. So coming on to the widgets, it has two functions. One is build loading state, and build stock data display. So in the first function, we displays UI with the spinner and supports the stock symbol and company name, and also the stock data display has the stock symbol along with the company name and the current stock price. And later we have the dispose. When the WebSocket connection is closed, we need to ensure that the widget is disposed to the prevent memory leaks. So this is the top stocks page. So in the top stocks page, we can see the list of stocks that are on the trending right now. We have a search bar in it. So a text field is used for searching the stocks. And when the user types in the search screen, in this search bar, it displays the stocks related to the search. And then we have the stock list, the list of stocks, which is globally. It is generated by a calling function called stock.getAll, and the list is dynamically filtered based on the search str, which is updated whenever user types in the search field. And then we have another functionality from the stock list where each stock is displayed as a list tile inside a card. The tile displays the stock symbol and the name. In the navigation, the tile is tabbed. It navigates to the new screen, and which is a stock price to that screen, and that allows the user to detail information about the selected stock. And we do have a wrapper class which extends the state widgets, and we give key, which is a super key, and then we override the function where the user provides the context. If the user is null, then we have to return back to the authentication, else we will return to the home. So the key components in these include managing the state of the user. So, and then our user, a model that holds the user's authentication data and representing the current user. And it has two screens which is wrapped in it, which is authentication and home. If the user is null, it goes back to the authentication, and if the user is logged in, it shows the home screen of the login. And the logic flow is like that we have discussed.
So next we'll look into the services, specifically the authentication and database service. Let's start with authentication. The core breakdown for this is, first we convert Firebase user data into our custom user model. This helps us work with a simplified user representation across the app. Then we listen for authentication changes so we can track if the user is signed in or out in real time. And of course, we handle sign in, sign out, and error handling, printing error messages during sign in, registration, or sign out operations to help with debugging. Now, moving to the database service. This interacts with Firebase Firestore to manage user data, specifically used for updating and storing user-specific stock data. Each user is associated with a unique UID, which ensures that their stock data is personalized and securely stored. The core breakdown here is we have a method to update user data. It uses Firestore's set method to either create or overwrite the existing user document with new data. So if the document already exists, it simply overrides it with the updated values. Now let's take a quick look at future works, or what can be added going forward. Some advanced feature we are considering to include are AI-driven stock recommendation and predictive analysis, real-time notification for stock updates, market events, or breaking news, enhanced security features like multi-factor authentication, localization, so the app can support multiple languages and platforms, monetization options like premium subscriptions or ad-based revenue models, integrating machine learning such as sentient analysis or stock trend predictions, and even offline modes, so users can still interact with the app when they're not even connected to the internet. All these potential upgrades would greatly improve usability, security, and market competitiveness. Now, with that, we'll move into the implementation section before wrapping up with the conclusion.
So this is the code structure that we have created. We have modules, screens, authenticate, homes, and then the home screens. And in the services, we have the auth data that we have discussed, and there's a Wrapper class in the screens as well. So we look into, so I have clicked on the run, and this is how it looks like.
This is the starting screen which gets displayed. This is basically for signing in. First, we don't have an account, so we'll register. We'll enter an email address. Next, we'll go with a password. For the password, it has to be a minimum of 6 characters and then register. So it says, welcome back. New users and dashboard screen is opened.
So when the dashboard screen is open, you can see the list of the the available. So this is the my stock screen. So initially it says that the stock is empty and it's asked to add the stocks. And so if you can look here, there are various stocks that are available. We can look into those stocks initially, and then we can just select the stocks that we would just like to randomly, and then just select the stock. And then if you can see, here are the displayed stocks, and from here you can even go to the stocks of the data, the stocks data that's related. It's taking a bit of time because of the API, so it will take to load.
Here we also have view news. So when we click on view news, we can see the financial news which is getting displayed. So you can click on one news and so the URL opens. So we can see the news for this particular news feed.
So coming back here, as you can see, the my stocks that I have added, they are also being displayed over here. And in the top stocks, you can just look over the stocks that are trending right now, and the which are having the stocks. Like we have said, when you click on each, it will go back to the detailed explanation of the stocks, and you can search. Just you can use the search bar. So I'm trying to search for HA. So wherever the word like HA is available, it looks for the HA and it will just give you the stocks, and you can just go see there's a FB. So I'm trying to search for FB, so you can see that FB is being searched related to such things.
Next, we also have the setting options. So when we click on settings, we are able to update the username. For example, initially it might say welcome back investor. After updating the username, it now says something like welcome back stock you. So that update is reflected in real time, and that's how the username customization works. We also have a sign out feature. When we click on sign out, we are taken back to the home screen where it again shows welcome back, but we have to sign in again to continue. So that wraps up to the overview and implementation of Stockly. Now let's move on to the conclusion.
So coming back to the conclusion, the Stocky provides the personalized user-friendly platform for managing stocks. It emphasizes simplicity, as you can see that it is very user-friendly. It is very the basic oriented, and the real-time updates are also being displayed. For the future enhancements, aims to create more engaging experiences for the users so that they can have AI-related suggestions, and the averages the gap between the casual investors and the market insights. Yeah, thank you.